Hi guys, myself Manoj.M. Welcome to the MANJULA.K Manoj.M YouTube channel. Guys, in this video we are discussing NAND gate as universal gate. Okay, yeah. NAND gate as universal gate. That means we are going to implement the NOT gate, AND gate, OR gate, NOR gate, XOR gate and XNOR gate using the NAND gate. Okay. Let us write NAND gate symbol here. NAND gate symbol. Let it be A. Let it be B. Yeah. The output is y is equal to A dot B bar. Okay, right? Yeah, guys. Let us write the truth table here. Truth table. Okay. A B Y. Okay. Yeah. 0 0 0 1 1 0 1 1. Okay. Yeah. Yeah, we know that when any input is 0, output is 1, else output is 0. We know that 0 and 0 for the NAND gate, the output is 1 for 0 1, the output is 1 for 1 0, the output is 1 for 1 1, the output is 0, right? Yeah, guys, let's implement the NOT gate by NAND gate. Okay, I will change the color to blue. Yeah, right. Yeah, NOT gate by NAND gate. Yeah, guys, you are seeing the truth table that when the input is 0 0, the output is 1, and when the input is 1 and 1, the output is 0. By simply shorting the input, we can get the inverter. Yeah, right. Yeah. A y is equal to A bar. Okay. Then next, let us move to the next one, that is AND gate by NAND gate. Okay, AND gate by NAND gate. Yeah, it's simple as that. First we write the NAND gate and then we put the inverter. It will become AND gate. Yeah, right? Yeah. A, B, next this one. Then put it to the NOT gate. That is by shorting these two. And then, yeah. Let us raise the output. I will change the color. Let us take this green. Here the output is A dot B bar and here A dot B bar whole bar. You know that will y is equal to A dot B. Okay. Then next move to the next one. Okay, that means OR gate and NOR gate by NAND gate. Okay, OR gate and NOR gate by NAND gate. Okay, yeah, guys, let us consider a equation y is equal to a bar dot b bar whole bar. Yeah, where it can write it as by the De Morgan's theorem. A bar whole bar plus b bar whole bar, that is a plus b. Okay, we know that a bar whole bar is a, b bar whole bar is b. Yeah, right. Yeah, let us implement this using the NAND gate. Okay, first we need the a bar as the output, right? For that, take this a, short this. We know that it will become the NOT gate. Here the output will be a bar, right? Yeah. And for the B bar, yeah, short this, give input to the NAND gate. Okay. Yeah. Here the output will become A bar. Here the output will become B bar. Okay. And then give it to the NAND gate. Okay. Yeah. Right. I will change the color here to explain you. Here it will come as A bar, B bar, whole bar. We know that will become A plus B. Simply write Y is equal to A plus B and then give it to the inverter, that means the NOT gate, and then it will become the NOR gate. Okay, yeah. Y bar is equal to A plus B whole bar. Okay. Yeah, guys. Here we implemented the OR gate and the NOR gate. Yeah, let's next implement the XOR gate and XNOR gate by NAND gate. XOR gate and XNOR gate by NAND gate. Okay. Yeah, guys. Let us first I will write the circuit and then let's discuss. Okay. Yeah, this one is A, given it input to the NAND gate, and then here B, given it input to the NAND gate. Okay. And then here the NAND gate. Okay. Here the output of this will given as input to this and also to this one. Okay. Yeah. And then output of this given as input to the NAND gate. Okay. Yeah. Let us discuss the output. I will change the color. Here it is A. Here it is A, B, but here it is B. Yeah, guys, here the output will be A dot A B bar whole bar. Okay. Then that will become A bar plus A B bar whole bar, and then A bar plus A B. It will become. We know that A B bar whole bar is A B, and then by the distributive light can be written as A bar plus B. Okay. Yeah. Let us write that. I will change the color. Okay. Yeah. Write it here as A bar plus B. Okay. And then here, let's solve the same thing here. Here the output it would be here, that will came as B dot AB bar whole bar, that can be written as B bar plus AB bar whole bar. It will become B bar plus AB. Through the distributive line, it will become B bar plus A. Okay. Write B bar plus A here. Okay. Yeah. Let clearly join this. Okay. Yeah, I will change this color, and then these are the inputs to the NAND gate. A bar plus B, B bar plus A whole bar. Let's multiply this. A bar, B bar plus A bar, A plus B, B bar plus B, A, right, whole bar. We know that A dot A bar is 0 and B dot B bar is 0. Yeah, right. Then it will become A bar, B bar plus A, B whole bar, right. Here we know that this is the output of that. If we not consider the complement, it will the output of the A bar, B bar plus AB. It is the output of the XNOR gate. Yeah, since there is a complement, we can know that this is a XOR gate A bar B plus A B bar. Okay. Yeah. Let us write y is equal to A bar B plus A B bar 8 y A. If we give it to the NOT gate, that means the inverter, it will become the XNOR gate. Okay. Yeah, here that will become y bar is equal to a bar b bar plus a b. Okay, that's it, guys. I hope you understand the NAND gate as XOR and XNOR gate, and the NAND gate as OR and NOR gate, and the NAND gate as AND gate, and the NAND gate as NOT gate. I hope you clearly understand the concept of NAND gate as universal gate, why we call that as universal gate. If you have any doubts, you can comment in the comment section. Thank you for watching, guys.